Hello friends, welcome to my YouTube channel. So today's onwards I am starting 12th class maths passing package series. So in this series I will try to explain the concept as simple as possible. So today I will discuss unit relations and functions. One of the important concept that is come for 5 marks. The concept is one and onto related. So one to one, in simple word, one to one meaning is, suppose if you consider a function's domain 1, 2, 3 and their image A, B, C. So here one input or one domain have only one image. One element have only one image. Such function is said to be 1 to 1. Same way, if you consider same domain 1, 2, 3 and image A, B, C, here two elements of domain, these two elements have same image, then such a function is said to be many to one. So 1 to 1 in the sense all the elements, each element have only one image. Each element they have only one image. Many to one in the sense if two elements have same image means they are many to one. Same way on to word meaning is if all the images are paired then they are said to be onto. If here observe all the images they are paired with some other element, so they are onto. If any one image is unpaired means they are not onto. If any one is unpaired means they are not onto. Now we will solve the question. Check the injectivity and surjectivity of the function f from R to R defined by f of x is equal to 3 minus 4x. Is it a bijective function? So here injectivity means they are 1 to 1 and surjective in the sense onto. Now we have to show whether this one is 1 1 or onto. To solve such a problem, one common pattern is that suppose imagine f from x to y. F from x to y. This is a function. To show whether the function is 1 1, we have to use a general pattern, that is x1 comma x2, that is belongs to this x first term after a first term. So x1 comma x2 that is belong to this x such that f of x1 that is equal to f of x2. And after the simplification, we have to show x1 is equal to x2 is said to be 1 1 or injective. Same way, to prove whether the function is onto, we have to show first general element y that is belongs to this y, such that f of x is equal to y, and you have to do some simplification. After the simplification you are getting x value. You have to show that x value is belongs to this x. If they belongs to x means the function is onto. So this is a general pattern to solve 1 to 1 and onto related function. So in any function first you have to show x1 x2 that is belongs to x. After that equal to f of x2, and finally after doing simplification you have to show x1 equal to x2. Same way, to prove the function is onto, you have to take first y element which is belong to this y, such that f of x is equal to y. After some simplification you have to get x value such that they must belong to this x. So now we will solve this problem. So here f from R to R, that is the function. So f from R to R is a function. F of x value that is given 3 minus 4x. So first take let x1 comma x2, this is a general pattern. Let x1 comma x2, that is belongs to x, that means first term, that is r. So let x1 comma x2 belongs to r such that f of x1 is equal to f of x2 such that. So x1 comma x2 belongs to this r such that f of x1 is equal to f of x2. So f of x1, we have f of x value, that is 3 minus 4x. Now in place of x, put x1. So that time you are getting 3 minus 4x1, which is equal to 3 minus 4x2. In place of x, you have to put x2. So now 3 they get cancelled. Minus 4x1 minus 4x2. So minus 4 get cancelled, and lastly we are left with x1 is equal to x2. Since x1 is equal to x2, therefore f is 1 1, or here f is injective. Both meaning are same. So therefore f is injective. Now it's time to show function is surjective or onto function. So now consider let y belongs to the second term r. Let y belongs to r such that f of x is equal to 1. Let y belongs to r such that f of x is equal to y. Now f of x value, that is 3 minus 4x. 3 minus. Rearrange the term so that we have to get this x value. So first 4x minus, keep here only, y minus 3. Next keep x here only, y minus 3 divided by actually minus 4, right? Minus here only, minus 4. So this term belongs to r. This term belongs to r. Therefore f is surjective. We are already proven f is injective. Since f is injective and surjective, therefore f is bijective function. So finally you have to give a conclusion. Injective and surjective. Injective and surjective. Therefore f is bijective. Therefore f is bijective function. Now we will solve second question, that is verify whether the function f from n to n, that is defined by f of x, that is equal to x square. F of x is equal to x square is 1 1 onto and bijective. First we will see whether it is 1 to 1. So 1 to 1 general pattern, that is let x1 comma x2, that is belongs to function f from n to n. So function n. So let x1 comma x2, that is belongs to n such that f of x1 is equal to f of x2. So we have f of x is equal to x square. Put x1 in place of x. So that time you are getting x1 square is equal to x2 square. So square get cancelled and you are left with x1 is equal to x2. Therefore function is 1 1. Same way to show whether the function is onto. So therefore f is 1 1. To show whether the function is onto, first let y, that is belongs to this n. Y is belongs to n such that f of x is equal to y. So f of x value, that is x square. X square is y. So we need a value in terms of x. So that's why x is equal to root y. Whether this root y belongs to n natural number set, just imagine if 1 is belongs to n, we know that 1 is a natural number that is belongs to n. Whether this root 1 belongs to n? Never, no? Same way, this root y does not belongs to n. Therefore, f is not on. Here f is 1 1 but not onto. Therefore, f is not a bijective function. Not a bijective function. Bijective function definition is, if function is both 1 1 and onto, then only the function is bijective. If condition fail, then function is not a bijective. State whether the function f from R to R defined as f of x is equal to 1 plus x square, we have to show whether it is 1 1 onto or bijective function. So here function f from R to R. Now it comes to real number. In case of natural number, we have x value only a positive integer. But in case of real number, x square, that is equal to plus or minus x. X square means they are maybe plus x or minus x. So now first we will show whether it is 1 1 or 1 2. So let general pattern x1 comma x2 belongs to R. Let x1 comma x2 belongs to R such that f of x1 is equal to f of x2. So f of x1 in the sense, put x1 value in the place of x. That time 1 plus x1 square, which is equal to 1 plus x2 square. So now here 1 1 they get cancelled. x1 square is equal to x2 square. But here x is a real number. That's why this x1 is equal to x2. This value may be plus or minus x2. So in all condition, it is not necessary that x1 must be equal to x2. For example, if you consider 2 square minus 2 square, both have a value 4 is 4, but 2 is never equal to minus 2. Therefore, f is not 1 to 1. Now we have to check whether it is onto. So let y belongs to R such that f of x is equal to y. So f of x, that is 1 plus x square is equal to y. X square is equal to y plus 1 become here, when shift right hand side, that time it become minus 1. So x is equal to root y minus 1, which belongs to R. Therefore, f is onto. Here f is not 1 1 but f is onto. Therefore, f is not a bijective. Therefore, f is not bijective.